Okay, great. Thanks for bearing with me for a minute or two. We had a little technical hiccup. Plugged my laptop in, and even with a couple different dongles, we weren't getting anything. So I'm going to my backup iPad. Always bring an iPad. These things are useful. My name is Kelly Morrison, and today's talk is about creating intuitive APIs with the builder design pattern. To give you a quick background about who I am, here's some of the companies I've worked for. I've been in the industry for a very long time. I have a doctorate in computer engineering from Auburn University, so War Eagle, and also a bachelor's degree in mathematics from the University of Georgia, so Go Dogs, which probably isn't very favorable here in Ohio, so feel free to throw things at me. I've worked for a number of companies over the years, like CNN, Turner, Home Depot. I've worked at anything from like small startups to big corporations. Right now, I'm a consultant for CGI. They're one of the two gold sponsors here today, and I'm working with them on a contract with Edward Jones Investment Company. So that's a little bit about me. I'll have some contact info at the end of the presentation. Before I get started on the builder design pattern, I'd kind of like to set the stage a little bit. What you're looking at here is a tweet I saw about 2 months ago. This guy was talking about vibe coding. He's like, hey, guess what? I just vibe coded an app, didn't write a single line of code. I've got it published out there. I'm making money off it. And if you're not doing this, you need to get off the program. Well, as luck would have it, karma struck just a few days later, and karma is pretty evil sometimes, almost like my ex-wife. And what happened was, he posted another tweet, and he said, I don't know what's going on here. Stuff's just appearing in my database. I've maxed out using my API keys. Weird things are happening, and I don't know enough about the code to fix it. And this is going to be a problem for a lot of us. Because as we're generating more and more AI code, this is basically what we're looking at. We're having AI generating huge heaps of code. A lot of it's really bad. I've looked at a lot of it. And we don't know if it works. We don't know how good it is. We don't know if there's some hidden security flaw that's going to put us on the front page of the news. So this is something we got to be careful about. And what this means for us is that it's going to change what we do. AI can generate code, and a lot of us are worried, hey, if it can write programs, we're out of a job. And it's not really the case. For one thing, at least for a time period, humans have to be able to understand the code, because when something breaks, we've got to be able to go in and fix it, especially when the CEO is calling up. It's like saying we're losing $1 million a minute. Somebody's got to get up there, even though it's 4 a.m. We got to get this thing fixed. Another thing about AI code, does it even work? I've had a lot of problems with AI just hallucinating solutions. It'll make up an API and use it, and then when I ask it about it, it's like, oops, sorry, yeah, you're right, that API doesn't exist. How about this one? So it'll lie to you sometimes, hallucinations. We got to make sure it's secure. The guy that tweeted that, he was talking about people were hacking his code and putting things in the database. He doesn't know how it was working. So we got to make sure it can generate secure code. We got to make sure it's solid code. If you are doing, say, you're entering a person's name, you want to make sure if you skip the last name, for example, you're Madonna or somebody like that, you don't enter a last name, you want to make sure it doesn't blow up on you. We got to make sure it's efficient, because we don't want to burn a lot of time, especially if you're doing something with AI that's doing image generation. It's just chewing up the dollars in the background. And we want to make sure it's testable. Just because it gave us code doesn't mean it works. We want to be able to test it. So what this means for us, if code generation is easy, but if specifying is hard, that means we're going to have to move away from what I call nuts and bolts programming, actually just writing the stuff. And we need to become architects. We've got to get better at telling the AI what to do. We basically all got a promotion. We're all going to be managers now. We need to tell this new AI team what to do. So one of the things we can do to get in that new mindset is learn more about architecture. There's a lot of great books out there. Neil Ford's written a number of great architecture courses. Something else you can do, right now on a lower level, is to learn about design patterns. These are time-tested patterns for how to write software. They've been around for a long time. And AI doesn't default to those. If you just tell AI to write some code, it writes what I call big dumb code. It doesn't try to architect it and make anything nice or extendable. It just spits out what I call big dumb code. So what we need to do is learn how to tell it when to use design patterns, especially when it's appropriate to do so. And then we can try to trick it into giving us better code. If you think about it, AI was basically trained on all the existing code it could find. It just sucked up everything in GitHub or in AWS. And it's really pattern matching. If you tell it to do something, it won't tell you the best solution. It'll tell you the most common solution. It's basically doing statistical like matching under the hood. So the most common ones will usually be average code. It won't give you like, bad stuff like student projects, but it also won't give you the really good stuff, the kind where you just sit back and think, yeah, that's really nice code. So it just gives us mediocre code, and as it trains on the code that it generates, it's going to get more and more mediocre. So we need to learn how to prompt it to give us better code. Today I'm going to give you a specific example of one of the design patterns. We look at the builder design pattern. You probably used this and not realized it. It's a very easy pattern. And what I'm going to do is try to explain to you what it does, how it's better than using regular constructors in a programming language, and give you some hints about when you can use it to generate better code. And later on, we'll see how ChatGPT does when we give it some hints about that. Okay, what is a builder design pattern? Has anybody here worked with it before? Okay, I see a few hands out there in the blinding light. Okay, the first time I heard about builder pattern was in an old book called Design Patterns. This is by the Gang of Four. I hear a few chuckles out there. Yeah, it's a great book. It's a very academic book, but it is a great book. Actually, how many people here have read this? Okay, good. If you're looking for a great book, I would look at it. There's also the lesser-known sequel to it, Pattern Hatching, which is a good book. It talks about one or two of the patterns they left out and has like some further thoughts about things they left out of the first book. But anyway, the problem with this is that most people look at it, they jump into it, and as I said, it's a very academic book. So you start looking at it, most people's like first impression is just like, forget that. I already went to school, chuck this in the trash. Well, years later, there was a little bit better explanation. Joshua Block, you've probably heard of him. He's responsible for a lot of stuff we take for granted these days. He wrote a book called Effective Java, and in it, he introduced a variant of the original pattern. It's a little bit different. It's kind of a combination between the original builder pattern and what I call a factory. But it became a very popular variant. Everybody started using it. Now you see it in just about every framework. And that's the one we're going to look at today. So I'm going to start off with a very simple explanation. One of the things I like to do when I'm talking about something is try to explain it without using computer terms. If you can understand the idea in the real world, it's usually really easy to map that into something that you can code. Also, if you get really good at explaining things without technical terms, you become management's best friend. For example, if you can explain something that people can understand, management might come over and say, hey, the AI team is talking about doing something called RAG. And I know they're talking about taking cloths and dusting the server, so can you explain that to me? And if you can do that, you're going to be their go-to guy. And that helps with job security, so that's a good skill to learn. Basically, if you think about it, elevator pitch, a builder is basically a better constructor. We've all used constructors in languages like new point, new graph, whatever. And that works fine a lot of the time. But there are cases where it kind of breaks down and we need something a little bit better. And that's where the builder design pattern comes in. What a builder does, you ask for a builder, you give us some instructions on what you want, and then it'll configure and build it for you. And that's it in a nutshell. Okay, let's take a couple of some examples. Like I mentioned earlier, you've probably seen this before and used it. If we go to Java, here's a couple examples that have been in there for a long time. Java has a string builder class. And what you can do is you can ask for a string builder. You give some instructions like, stick these strings in there, and they'll build me a string. Later on in the Stream API, they added something very similar. There's a string builder, you add a couple things, and you tell it to build. So again, this is what we just looked at. You ask for a builder, you give us some instructions on what you'd like, and then ask it to build it for you. Here's another example, Spring. How many people here use Spring? Okay, yeah, feel for you. I've had some headaches with that. Here's a couple of examples from Spring, and I'd like you to notice that they're all kind of similar and different at the same time. These are three Spring APIs for basically dealing with web connections. The first one's a web client, and you can see it calls webclient.builder. Then it gives it a couple of configuration items, like here's an URL I'd like to call, here are the headers and cookies, and then it builds you a web client. For REST templates, instead of calling webclient.builder, you just create a new builder class. And that's the same thing. You configure it, and then you hit build. It creates a REST template. For URI components, is still a third way of doing it. You create a new instance of a builder. You do a couple of configuration things, and then you build it. So even though like the way you call a builder differs, even in the same framework, I don't know how they missed that, it's the same pattern. You create a builder, you give us some configuration information, and then you tell it to build the final object. One more example, does anybody use Guava? This is a library that Google developed. It's kind of on its way out, but I've got a lot of use out of it over the years. It has some classes for doing things like immutable list and building caches. And again, you ask for a builder, you give it some configuration information, and then you ask it to build something. Same thing for cache. I want to build a cache. You can hold 100 things in it, expire after 10 minutes, and then build it. Okay, so you've probably used some of these before, and like I said, the details might differ in how you create the builder, but the idea is the same. You get a builder, you give it some instructions, and then you tell them to build something for you. To use a real-world example, I like thinking of a builder like a waiter in a diner. Like I mentioned earlier, the design patterns book is very dry and academic, so I usually try when I read that book to relate everything in it to things I know in real life. And the example I came up with for the builder pattern is ordering something in a restaurant. So let's imagine we're a customer, we walk into a diner, and we want to get a meal. The waitress comes over, and I think of her as a builder. And she's got a notepad. If she comes over to the table, she's going to take down instructions. Okay, that's when you give your order to the waiter, like a burger, fries, and a Coca-Cola. And this is where the waitress says, we don't have Coke, it's Pepsi. And that's where you throw up your hands and stomp out, but maybe that's just me. But anyway, the customer gives an order to the waiter. And they give several things, like here's what I'd like for an entree, here's what I'd like for a drink, here's what I'd like for dessert. You can change things easily at this point. I might say I want a rare steak. My ex-wife would glare at me. It's like, okay, give me a well-done steak so she can eat part of it. But again, that's an easy change. Nobody's like, cut a steak or put it on the grill. Nobody's done anything yet. Right now it's just scribbled instructions on a notepad. So until you commit, you can tell the waiter anything you want. And you can change things easily. When you're finally done with the order and the waitress says anything else, and you're like, no, I'm good. That's when the waiter takes the order to the chef. And that's when the chef actually commits and builds something. That's when he cracks the eggs, and that's when he throws the steak on the grill, he tosses the salad. At this point, we're committed. You're actually building something. He finishes the meal, he hands it to the waitress. The waitress looks it over and says, yeah, you gave me a Coke. He wants a Coke, but this is a Pepsi. That's not going to fly. Go back and switch it out. Or this fried alligator is too cold, or you forgot the remoulade sauce. So anyway, you check things over, make sure everything's good, and then once everything looks great, then you bring out the finished meal to the customer. And if you understood that, you know how the builder pattern works. That's basically the wax on, wax off description. So now that you've looked at that, let's go back and see how it actually looks in code. Okay, here's an example of building a name, first name, last name. And what we can do is create a simple builder. We set a first name, last name, and then we tell it to build a name for us. And to relate this back to our diner example, the thing we're building, a simple name, that's kind of like the meal that we went into the place to get. When you create a new simple name builder, that's like asking the waitress to come over to your table. The setters there, set the first name, set the last name. This is you telling the waiter what you'd like. You're giving her instructions. Then once you're done with that, you tell her to build it. That's when she takes it to the cook. Cook cooks it, she checks it over, and then she brings you back your final meal. So this is how, a diner example relates to the builder design pattern in code. Okay, let's look under the hood and take a little bit better look at how a builder's implemented. By the way, all this images I've been using are AI generated, so if you get bored, start counting fingers, look for an extra nose, that kind of thing. But if you want to use the simple name builder we just created, here's how you would do it. It's pretty simple. You just create a builder, set the first and last name, build it. Good to go. Under the hood, here's what it might look like. The simple name, this is like the meal you want to get from the restaurant. It's pretty simple. We just have a couple of final fields for first and last name. We set the first and last name in the constructor, and then we have a couple of getters to get those. The builder you can think of as like an accompanying class. I like creating them as a static class inside the thing. And you can see it's got a copy of everything, like first and last name, but instead of being final, you can change these. We also have setters here. You can set the first name, you can set the last name, and then you have a build method. So what will happen is you'll create a simple name builder. You call the set first name and last name on that class. And then when you tell it to build, it will go back and create a simple name for you. So basically, we've taken a regular class that has getters and setters. We've kind of like pried it apart into two different classes. The one on the left is the thing you actually want. And you can see this is what we call an immutable class, which means you can't change it. It has a first and a last name. They're private and final. And then there are getters for them. Meanwhile, this is the sloppy one that you can mess with to your heart's content. The things there, first and last name, you can change those. We've got setters for them, so you can change it a zillion times. But once you're finally done and you just call it build, that's when it actually builds your final object. So again, it's like taking a regular class with getters and setters and prying it apart into two different classes. Okay, this is the money shot for this presentation. If you like this one, this is basically the one thing you should carry home with you. In fact, you can print it as a glossy poster, you can upload it to Walmart and print it on a coffee cup. This is basically how you do a builder. And let's go through it quickly. The thing on the left, simple name, this is kind of like the meal you want to order in the restaurant. Okay, over on the right side, we have a simple name builder. Okay, the blue part there, I guess is blue. I grew up in the Deep South. I know 8 colors, so it looks blue to me. Hey, I also grew up in the 60s. We didn't have iPads with a zillion colors back then. Okay, but anyway, the blue part, and bear with me if you see a different color, the blue part is kind of like the waitress coming over your table. She's setting the instance fields there. They're kind of like her scratch pad. The part in the purplish up there, that's like the little scratch pad she brings over to the table. When you create a builder, she basically rips it off and gets a blank page. Then as the customer, tells the waitress what they'd like, I'd like a first name, I'd like a last name, you can think of it or her as like writing things down on her scratch pad. So for example, the set first name there, it's like the customer saying, I want the first name to be this. Okay, this dot first equal first is like her writing it down on her little scratch pad, the instance variables up there. And then return this basically returns the builder back. It's kind of like saying, okay, got a first name, anything else? And that's when you call the last name method on it and say, I want the last name to be this. This dot last equal last is like her writing that down on the scratch pad. And then return this is her saying, okay, I got that, anything else? And the customer saying, no, that's everything, is like them calling the build method, saying, that's it. Take it to the kitchen and bring me back my meal. So, the build method, actually, you can check things over here. And then you create an instance of simple name and return it. So this is how the build method works. This is code. You can copy, paste, use it anytime you'd like. Okay, now you're probably wondering, aren't we overcomplicating things? Are we becoming architecture astronauts? I mean, what's wrong with just using plain getters and setters? It's worked for 40, 50 years. Nobody's complained about them much. So no, there are good uses for this. Let's take a first name and last name. Let's imagine that it had actually been a class like this, where we have first and last are not final, and then we have getters for getting the names, and then we have setters for setting them. It's all in one class. What's wrong with that? I mean, this is Java 101. This was our first day of programming. Well, the problem is, the thing on the left, that thing is a mutable class, which means you can change it. And that in itself isn't a bad thing, but we're using more and more concurrency in programs today. And when you have concurrency in an object that can change anywhere at any moment, that gets to be a headache when you're debugging. So a good thing to do when you're doing concurrent programming is to have what we call immutable objects, objects that you create and you never change them again. You think of them as like a glorified constant. Okay, here's an example of why it's a good thing to have it. Here I've got a class called best picture. Let's imagine we're writing a program to get the best picture for the year. Okay, and here I wrote a sample program. There's a lot of code here, but the idea is this. We create a new best picture object, and then I create 2 threads. Each one will run 30 times, and then it'll try to set the name of the best picture. The first thread up there, every 15 seconds, every half a second, it'll wake up and say the best film is The Avengers. The one on the bottom will wake up every half second and say the best picture is Justice League. And then after they've run for a while, we like stop it and print out what best picture is. Can anybody tell me what this will print? No, you can't. Because every time you run it, you could get something different. Just for fun, I ran it 10 times. This is what happened. The first time it said the Avengers, then I had a run of Justice League, and then I came back and ran the Avengers twice. So that's a contrived example, but it shows you that if you have an object that can change and you pass it to more than one thread, you can get into some weird states, and those can be really difficult to debug. Okay. Now, you can fix this by making it immutable. Instead of being able to set the picture, you just create it and say, this is the best picture, and now you can only get the name back. Okay, so now we've got an immutable class. We're good, right? Well, no, there's still a lot of problems with constructors. Let's take a look at some of them. If you think about when you're creating an object, there are really two ways to configure it. The first way is to pass in information in the constructor. The second way is to have setter methods to set things after the fact. So you can either configure it during construction or you can configure it later with setter methods. If you take the first approach, configuring it through the constructor, it can lead to some really long constructors. For example, here I've got an employee class. It's got the usual things like first name, last name, salary, title, like birthday, what department you're in. You can imagine this goes on and on. If you try to create a constructor for this, it'll be a really long one. And it can also lead to some problems. If you look at the bottom in the main method where I try to create an employee, you can see I put in Tony Stark, Avenger, but there's a lot of nulls there. And if you were unfamiliar with this code base, you'd be looking at those nulls and thinking, what is that? Should I have something there? Is it okay to pass null? So it's not clear. So this is a problem. And there's also a bug here. Can anybody tell me what it is? Exactly. I've put Tony and Stark here as the first two arguments, but if you look up there, it's first name, middle name, and then last name. So I put Stark as the middle name, and then he doesn't have a last name. By the way, can anybody tell me what Tony's middle name is? Edward. Okay, you learned something. You can carry that home, play trivia tonight. Okay, so this is one of the problems with long constructors. It's easy to miss something. It's not clear what it's doing. It's also possible to create an object in an inconsistent state. Here I've got a fraction class. And you can see at the very beginning, we have declaring a numerator and a denominator and setting them to 0. Then we got a couple setter methods for setting the numerator and denominator. And then I have an as decimal method. And what that does is it turns the fraction into a decimal. Okay, if you look at the bottom, you can see I create a fraction, I set the numerator. It doesn't blow up until I hit as decimal, because then we get to divide by 0. Now, the problem with this is there might be a lot of code between that set numerator and when you call as decimal. I mean, it could be like 1,000 lines away, like 10 levels deep inside some function you've passed it to. In my point of view, it's kind of like somebody stabs somebody to death, throws them in the back of a train car, and then 5 days later, 8 states away, a hobo finds the body and hey, a murder happened, but you don't know where it was. And I apologize for the morbid example, but my father was a coroner, so that's kind of the first thing I went to. A better way to do that, and we'll get to it in a few minutes. Another problem with constructors is you can confuse a programmer by having too many methods that are unrelated. For example, let's imagine we originally had a payment method program, and we started off with credit cards. So we put in methods for a credit card number, expiration date, CVV. Then later on, somebody came in and said, hey, we need to do gift cards too. So instead of creating a new object, they just stuff some methods into the same payment method class for it. And then somebody comes along and says, hey, we need cash. So, hey, there's the dollars and cents. So now we've got this big God class. It's actually hiding several different kinds of behavior. And if you're unfamiliar with it and you come along and try to create a payment method, you might mix these up. For example, you might try to call the credit card number from the credit card part, set vendor from Starbucks, and then dollars and cents from the cash method. And in this case, it's pretty easy because we all know what these objects are. But if you're dealing with something that you've never seen before, the control thing for a drone, it might not be clear that these functions are related or not. So that's another problem with too many setters. At this point you're thinking, yeah, yeah, I feel like that a lot of times when I'm writing code. Well, the builder problem can fix these. We can use the builder pattern to address these issues. So let's go back through them. The first example where we had a long constructor, we were passing a lot of nulls. If you use the builder pattern, you actually have like a method for each one. So instead of having to pass a lot of nulls, you pass in like first name, last name, title, and then tell it to build an object. So it's more clear if you're looking at the code in a PR review or if you're unfamiliar with it. It reduces the possibility of making a mistake. In the first one, you might not see if you're just doing a code review that Stark's on the wrong place. And the second one, it's very easy to see that Stark is the last name. So it makes it more obvious about how to use the API. Here's what that would look like as code if you want to look at it. I know we're all anxious to see Thunderbolts, so I'll skip over it. But this is basically like what that code might look like. We talked about building invalid objects. Again, what we can do with the builder method is we create a builder, you set numerator and denominator. When they call build to actually build the fraction, this is where we can check to see if the denominator is 0. We can throw an object. So instead of the old case where you create a fraction, set a numerator, and then you're way down the line, it blows up. This time it blows up right when you try to build it. When you build the object, it'll blow up immediately. So instead of having the body in a train car for days, found in Nevada somewhere, Nevada, it's like a police officer coming along saying you stabbed the guy the first time. It's like, hey, stop that. So you catch the murder right where it happened, not far, far away. And again, I apologize for the morbid explanation, but I think of my code as a crime scene a lot. Not my code, the code I work with from coworkers. Okay, and now for something that'll blow your mind, multiple builders. Everything I've gone through so far is what you normally see when you have a builder tutorial or read about it. What I'm about to show you is a technique for using more than one builder to create an object. And I've never seen an AI generate this on its own without being prompted to do so. Like I said, AI will generate big dumb code. But this is a really elegant solution, and you can prompt the AI pretty easily to do this. So let me show you what I'm talking about here. Again, why are we doing this? We've already taken a constructor and kind of extracted it to a builder method. Why make it more complicated? Well, because it can make things a lot simpler for your end user. If we go back to our payment class, where we had credit card, gift card, and dollars and cents information in the same place, we could see it was easy to mix and match. You might say, here's the credit card number, and here's a number of pennies. And they don't really make sense to each other. What we can do is use multiple builders to fix this problem. And here's the idea. What we do is we create a builder like we normally do. But instead of being able to set everything in the class, what we can do is give it a couple of options up front. When you first create a builder, you say, hey, I want to create a credit card, or I want to create a cash payment method, or I want to create a gift card. And then, instead of returning the original payment method builder, what we do is we send over a different builder. So if they select a credit card, then we send them to a credit card builder. And this builder only has options that are relevant for credit cards. Similarly, if they pick cash, we take them to a cash builder, which only has dollars and cents. If they pick gift card, we take them to a gift card builder. So it only lets you set the card number and the amount of money. Then finally, all of these have a build method, which will create a payment method. So you can see this makes it pretty much foolproof for creating one of these. If the first choice you make takes you to another set of limited choices. And this will guide a person very easily. Okay, here's what the code looks like for something like that. We have a payment method, has all of our stuff. There's a private class that has all the stuff for the constructor. The builder, you can see when we hit credit card, we create a credit card builder and return it. Same thing for cash builder, same thing for gift card builder. Okay, and then for a credit card builder, it's like the ones we've already used. You have setter methods. When you finally build something, you create a payment method and return it. You do the same thing for cash builder and gift card builder. Okay, now when you're actually using it, here's some examples. On the top one up there, we're creating a payment method using a credit card. So we create a payment method builder, and you can see that returns a payment method builder for us. Then as soon as we hit credit card, it switches over and returns us a credit card builder. And then we can call CVV and expiration date. It'll set those and still return the credit card builder. When we finally hit build, that's when it actually creates a payment method and returns it. Same thing for the other two. For gift card builder, it returns a gift card builder when you hit gift card. Then you can always see the options there. Same thing for cash. So this takes a very confusing God class and breaks it down so it's easier for somebody unfamiliar with it to use it. They don't have to read 100 options and wonder, hey, is there one I'm missing that's going to make this fail? No, you break it down for them. So they only see the things that are applicable to them. Okay, if you were to look at this in an IDE, it looks something like this. You create a payment method builder, and you can see it only shows the top level methods. There's cash, credit card, and gift card, plus all the other stuff that IntelliJ shows you. Once you pick one of those, for example, credit card, now it breaks down. You can only see like credit card number, CVV, and expiration date. You don't see any of the others. And then when you click build, you've got your payment method. The first time I saw this, I thought, this is great. That is really slick. The problem is, AI won't generate this for you by default. You have to tell it how to do it. But it's a really slick method, and if you have people using your API, they'll be very thankful for it. Let's look at a couple more builder examples. Here's one for cars. And again, we might have a big God class for building cars. And what we can do is break it down into several different classes. You might want to build an electric car, gas car, or diesel car. So at the top level, the builder only has 3 methods: electric, gas, and diesel. If you pick electric, we switch over to an electric car builder. Same thing for gas, same thing for diesel. And then the all build method will actually build you a car. So again, we limited it at each stage so that you only see options that are applicable for the setting you've created. Okay, and here's what it looks like when you use it. You car builder, it's electric. And now you see options like large battery or small battery, home charger. On the other hand, if you pick diesel, you pick the size engine, like 8 liter. Okay, here's an outline of the code. Again, it looks like the other examples, so I won't really spend a lot of time on this, but it's in the PDF if you'd like to look at it. Final example, maybe a temperature builder. You might want to check between Fahrenheit, centigrade, and Kelvin. And this is actually a pretty dull class because the only thing you can really do is set the number of degrees on it and then build a temperature. But the reason I showed this is that sometimes when you set the number of degrees, it's different for each one. For example, it's easy to set a negative temperature for Fahrenheit. You can't do it for Kelvin. Kelvin goes down to absolute 0, and that's it. A negative number is an issue. So instead of having a if statement in your code where if it's Fahrenheit, then allow this, but if it's Kelvin, do that. You can basically isolate it. If it's in Fahrenheit, anything goes. If it's in Kelvin in the build method, you check to see if the temperature is 0. If not, you throw an error. And again, here's what that would look like. Okay, let's look at some enhancements to the builder pattern and how we doing on time, 10 minutes. By the way, I'm going to show you a couple of quick enhancements, and I've got examples in different languages. I'll probably skip over those since we got to get out of here to go see Thunderbolts. But they're in the PDF, and I'll show you the contact information in a moment. The first thing I'd like to talk to you, if you remember the first couple of slides where I showed you examples from different frameworks, and they all created a builder in a different way. Here's a common one I see a lot. I think this is what IntelliJ does for you. It actually creates a class called Employee Builder. And to me, that's a problem. We don't want to expose names of internal classes to the user. So what I usually like to do is add a static builder method. So if I'm building an employee, I create a builder method on employee that returns an employee builder. So that way, all I'll do is say, if I want to build an employee, I just call employee builder. That way it doesn't expose anything internal, and we can swap it out later. Next issue, how many people still use Lombok? A few people. Lombok was a framework for writing Java programs. It was heavily based on annotations. What you would do is write Java code and add a couple of annotations, and it would add all this functionality to you. The problem is, it's going away since Java is actually becoming pretty useful these days. They've been improving it steadily, and a lot of things that Lombok was originally used for are built into the language now. But one of the things that Lombok did really well was to create builders. To create a builder in Lombok was really easy. You basically declare a class, you declare private final methods for the things in it, and then you just add the @builder annotation to the class. And that's it. It'll create the builder for you. So it'll create methods, setters for them. There's another annotation called add getter, which adds getter methods to it. So if I wanted to build a DJ, I'll just call user.builder, set the first and last name, build it, and boom, got it. So if you're still using Lombok, this is something very easy to do. How many people are using Java 14 or better? A few, good. Yeah. How many people are still using Java 8? Okay, whew, good. Okay. I love Java 8. It was like Windows XP for me, but it's getting a little long in the tooth. Okay, Java 14 introduced the idea of a record, which is basically an immutable class. And you can actually use the builder pattern with records. If you've never seen it before, here's what it looks like. Instead of public class, something, you just say public record. And then the things that you pass into it, like string name and string presenter, these become private final fields inside the record. It'll also create getter methods for each one. So we pass in name and presenter. So it actually create methods called name and presenter that we can call. It also adds toString for you. It adds equals, and it adds hash code. So it does a lot, just in one line. Okay, to use the builder method with it, here's one way you can do it. Again, you create a builder like we always have, make it private static inside the class. To turn it into a record, what you can do is create a constructor for the record. And what I'm doing here is I'm actually passing the builder into it. And then inside the builder, I'm setting the name and the presenter into it. Now, this is a little different than what we've used before, and it's actually a pattern I don't like very well. Because what we're doing is we're taking one of our construction classes and putting it in the final object. And I don't like that. I'd really rather pass things in by name. But this is a technique you see sometimes. You just pass the builder itself and then pull things out of it. But anyway, that's one way of using Java 14 with it. How many people use IntelliJ? A couple. Okay. I used to use it a lot, but I've kind of switched over to Visual Studio Code. It can actually generate builders for you, and it's pretty simple. What you do is you create a class, a class employee, give it a couple final fields, and to create a builder for it, what you can do is right-click to get to show the context actions. One of the things in it, I've got the wrong thing highlighted there. If you go down 2, it says replace constructor with builder. If you select that method, you would think it creates the builder for you. No, it takes you to another dialog panel. But this one lets you, for example, change names of the setters. It gives you default values. There's a lot of other stuff for it. Usually I just click on through and hit refactor. And what it'll do is it'll create a builder for you. So here it is, this public class employee builder. And at the very end, it's called create employee. So it'll create a builder for you, but it's not what I would call a great one. And the reason for that is the builder is put in a separate file. I usually like keeping it in the file of the thing it's creating. It also creates a non-setter name for the build method. It uses create employee. I like just using build. That's kind of a common convention for it. Okay, well, let's go back to ChatGPT. At the very beginning, I said, ChatGPT won't create stuff like this for you unless you specifically prompt it. So here's an example of how I did it. And by the way, I think ChatGPT should be more inclusive. I'm from South Georgia, so every once in a while, just to switch things up, I'll use my rural South Georgia patois when I talk to it. So here I've got, reckon you could fix me up one of them builder patterns. Tell it I want an immutable Java class, called employee, first name, last name, and age. And then because I might sell this to the Department of Government Efficiency, I tell it nobody less than 16 or older than 130. And click on that, and it actually understood my redneck garbled, instructions, and it created a perfect builder for me. Here's what it created. It looks just like the ones we've looked at in our examples. It's got first name, last name, age. We've got a private, constructor, got setters. Inside the set age, it actually checks for out of range conditions, and then we got a build method. So if you tell ChatGPT to create a builder for you, it'll do it. Okay, we're about out of time, so I'm just going to skip through these really quickly, but they're there if you want them. How many people use Go? A couple people, okay. Go is an interesting language. It doesn't really have classes. It has basically structures, and you attach functions to it. If you want to create a builder in Go, here's an example for you. It's in the PDF file. What about, here's how you use the Python version of it. Use TypeScript. I'm sure we all do it. you can implement builders in TypeScript. Again, here's an example. It's in the PDF file. If you need to get it, you can copy paste out of there. Here's what it looks like if you use it in TypeScript. And now, summary takeaways. Hopefully, you've got a better idea of what a builder is. We've seen some of the reasons it's better than a constructor. For example, like you don't have to pass in a zillion arguments. You don't have to pass in nulls. It's easier to get it configured properly instead of slipping up. Like, oops, I put Tony Stark in the wrong place, and now I've got Tony Blah. You can use multiple builders to simplify construction. This will make it really easy for other people to use your code. Builders also let you do fail fast. If you just have setters, again, it's like somebody killed somebody and put them in a train car and it blows up like down the road. With builders, you find it out right away. So it's easy to find out where things went wrong. They work great with Java 14, the records. You can also use them to gate the creation of objects. Since you're not doing new blah all through your code, but you're saying, hey, build me an object, the builder can actually keep a cache of objects. For example, you might want to only allocate 10 of something at a time. So when you create build, it can check and see if it's got one. If it does, it can return a cache version. If it's out of them, it can say, hey, I can't do that. So that's another thing you can use. And again, if you know something about builders, it can help you generate better code. So that's pretty much it. Here's a link to the slides. There's also a link to them inside the the Discord channel. Here's a link to my LinkedIn information. Feel free to give me a comment on there. Here's my email address. And again, I work for CGI. It's a great company. If you're looking for a job, you want to come check with us. And that's my cute little dog, Daisy Mae, who's sitting back in Savannah wondering where I'm at right now. So I'll be back with her tomorrow. Okay, that's it. And that's a wrap for Stir Trek 2025. Thank you. This has been my first time here. Hope everybody else had a great time. Thank you. If you have any questions, stick them in the comments in Discord. I'll get back to you or email me. And also, if you like to talk, just post something there. Maybe the organizers will see it and bring me back again.